control. Last class we discussed together the adding resistance and voltage speed control. We will continue in the other speed control techniques. In the last class, Shabab, we discussed two different circuits to control the voltage, which are AC chopper and PWM AC chopper. The difference between the two topologies is that for the AC chopper or conventional AC voltage controller, we use thyristors. However, this is thyristor. However, for the modern or PWM AC voltage controller, we use switches like IGBTs and MOSFETs. The difference, Shabab, يعني simply IGBT and MOSFET can work at very high switching frequency, and this is going to make the circuit very fast. And if the circuit is very fast, the response of the circuit will be also very good, which means you have lower harmonic contents. Okay, and at the same time, because you have lower harmonic, the torque ripples of the machine will be small. يبقى torque ripples will be lower. ليه? Because we have a small harmonic contents compared to the other AC chopper. Also, for the AC chopper, Shabab, which is based on thyristor, the part of the waveform which is removed from here, it will be injected on the grid, which means it's harmonic, which means it's rejecting harmonics to grid. And this is going to affect the surrounding loads as well. Besides, the harmonic itself will also affect the core losses of the machine. So here, beside the lower harmonic contents, the torque ripple will be smaller, and also it will reduce or make the losses lower core loss. لأن شباب الcore losses are a function of frequency or depending on frequency. Okay, so if you have small harmonics, because harmonics شباب are considered as high frequency losses. تمام؟ Harmonics causes high frequency losses. So if you have lower harmonic contents, this is going to make the core losses lower. طبعا lower I mean compared to conventional techniques. تمام؟ So we prefer PWM circuits instead of conventional circuits. I mean circuits because we have PWM AC chopper, we have PWM rectifier, we have PWM inverter, so we have many PWM circuits. Here we are speaking about AC chopper because we need to control the voltage of the machine. So for AC chopper, we have either the AC chopper based on thyristors on the previous slide, and based also on IGBT and MOSFETs, which are controlled by pulse width modulation. Right. And you have an activity to search for the PWM converters and their advantages compared to conventional converters. Now let's solve some examples and continue discussing the different speed control techniques. Here, the example says for the motor given in example 1, assume that the load torque is constant and equals 120 Newton meter. Ignore the rotational loss or losses and calculate the motor speed at full voltage. So firstly, we need to calculate the motor speed at full voltage. So it's not speed control now, it's just normal problem. Then repeat the computation if the voltage is reduced by 20%. So now we are going to test the motor or find the performance at full voltage. Then we will reduce the voltage by 20% and record our performance. Here in the performance, we need only to see what will happen to the speed. Because it's steady calculated the motor speed. Fine. Let's start at the beginning. We have torque load equals 120 Newton meters, and at full voltage we need to calculate the motor speed. طبعا simply يا شباب, as we said, for operation at steady state, we can assume the linear relation between torque and slip, which is coming by neglecting value of X equivalent square and R1 compared to R2 prime over S. So this is our relation, and now we can substitute in this relation. We can say now torque developed 120 equals V squared. V was given in the example, in the nameplate data. It was 480 line يا شباب. طيب, in this equation, should we represent the machine in phase or line? ها شباب?
Line.
If we multiply it by 3, it should be phases.
Yes.
If we do not, it will be line. This is only in Y connection يا شباب. However, general relation is torque developed equals 3 V phase square S over omega S R2 prime. Here, because the machine is Y connected and you have V line equals square root of 3 V phase, so you can replace 3 V phase square by V line square. تمام يا شباب? However, if the machine is delta connection, you cannot do that. You have to multiply here by 3. صح ولا غلط? So here we can substitute by the values we have, 480 squared, which is the line voltage squared, multiplied by slip over omega S. Omega S, what is the value of omega S يا شباب? Is it electrical speed or mechanical speed?
Electrical speed.
It's mechanical speed يا شباب. Mechanical speed. It's not electrical. Electrical speed equals 2 by F. Electrical speed is 2 by multiplied by frequency. Because I found some of you doing these mistakes in lab. Omega شباب, omega S equals 2 pi over 60 multiplied by RPM, which is 4 by F over number of poles. So omega S equals 4 by F over number of poles, which is equal to 2 over P multiplied by omega S electrical. Omega S electrical, which is 2 by F. تمام؟ يعني if you substitute by 2 by F here, you will get the mechanical speed. ماشي؟ So omega S here, we are working with mechanical speeds all of time here in the machine models. طيب. So omega 2 pi multiplied by 1200 RPM, which is the synchronous speed. Why? Because in this machine, it was stated in the data given in example 1 that number of poles equals 6 and the frequency was 60 hertz. So if you substitute, you will find that NS equals 1200. طبعا multiplied by 0.5, which is the value of R2 prime يا شباب. So we have only one unknown here, which is S. So we can get S easily. After getting S شباب, we simply can substitute in the equation N equals 1 minus S multiplied by NS to get the motor speed. يعني this line يا شباب written in red color is missed in your slides as well. يعني please write it and I will update it on Blackboard إن شاء الله. طيب, now يا شباب we calculated the speed. تفضل.
So we said that omega S is the flux speed, right?
Omega S is the flux speed. Yes, this is right. However, flux speed means rotation of the flux in the air gap. So is it electrical or mechanical now?
So it should be electrical, right?
No, it's not electrical. It's not electrical. Moving of flux in the air gap, it's motion. It's mechanical motion now. Okay? It's mechanical motion. It's not electrical motion. Because now it's a function of number of poles of the machine. Okay? However, electrical motion is a function of frequency only.
Yeah.
Okay.
I have the same issue, Doctor.
تفضل.
We calculate it as per the frequency, so that means this is almost synchronous speed, am I right?
Yes. This is synchronous speed.
How can we consider it as a mechanical speed?
يعني whatever synchronous or motor, it's still mechanical. يعني mechanical speed, it means you have a real particle or a real system moving and rotating. You can recognize this speed and measure it. However, electrical speed you cannot measure. You can only see the electrical speed on يعني from the current or from the voltage, from electrical quantity, not from mechanical motion. Okay.
Okay. Is this speed? Is it a shaft speed?
Not shaft. It's synchronous speed.
Okay. Okay. Now it's clear. Thank you.
Right. Now, شباب, we calculated the machine speed at rated values. If the voltage now reduced by 20%, what do we expect, شباب? What will happen if we reduce the voltage by 20%? In terms of maximum torque, what will happen? For the maximum torque, شباب.
Decrease.
It will be decreased, exactly. Right, for the starting torque, is it going to decrease or increase?
Also decrease.
طيب يا شباب, you have to recognize all of this for all machine types, for all of speed control types. يعني it may be يعني as MCQs in the exam. Okay, so you should be familiar with all of the parameters. What will happen if you make speed or different speed control techniques? Voltage, frequency, V over F. Okay, so you should يعني recognize all of the changes. طيب. So now for the speed يا شباب, normally if we plotted the characteristic of the machine like that, assume this is at voltage of rated, and this is here the S maximum locus for both of curves. So expect the second curve may be like that. Sorry. صح يا شباب? So if you have constant load torque, for instance this one, so what do you expect the speed? ايه اللي يحصل يا شباب للسبيد؟
Decrease.
Speed will be decreased. So the speed now has been decreased from this point to that point. However, it's not a wide range of speed control as we discussed before. So the change in the speed will be limited. طيب, let's now see how we can get the control or the relation of our speed control now. Again, يا شباب, we discussed previously the table for the different speed control techniques and different load techniques. Here, you have constant load torque, which means T1 over T2 equals unity. This is what we have here, TD new over TD, which we have different subscriptions there, 1 and 2. TD new over TD old equals unity because it's constant load torque. It's 120 Newton meters. So it's constant. So this is equals, in terms of the machine parameter, V square multiplied by S over V square old multiplied by S old. This is now according to our machine relation. So this is here representing the load torque relation, and this here representing the machine relation. Type. طبعا you can extract this from the table easily. Now you have V new, which is 0.8 V old. So we can say now 0.8 V over V old square like that, multiplied by S new, which is required, over S old, which we have calculated previously. Okay, S old was 0.0327. This is equals 1, so you can get S new here easily. تمام يا شباب? Is it clear? After getting S new, now you can substitute in the machine speed. What will be the value of NS? Is it different, شباب, or constant?
NS is the same.
It's the same here. طب why is the same? What is the relation of NS? NS equals شباب, حد يشارك معانا غير رضا حد يشارك معانا شباب غير رضا وهشام, يعني هم اللي بيشاركوا على طول.
120.
It's 1200. Our relation 120 multiplied by frequency over number of volts. So if we change the volt, is the value of synchronous speed will be changed? It's constant. صح كده يا شباب? So this is now the value of NS. So 1 minus S multiplied by NS. This is now the new speed. As you can see, 1139. Previous one was 1160. So it's not a big change in speed. تمام? So يعني if you calculate here the reference يعني it's stated that it's 5%. يعني I didn't يعني honestly I didn't calculate the difference, but it's يعني we can calculate now. It's 1139 minus 1160 over 1160. It's not يعني 5%, it's only 1.8. okay, it's only 1.8 يا شباب. ماشي، يعني this percent is calculated wrongly in the reference. يعني here this one is 1.8% change. How I get this value? I just subtracted 1160 minus 1139 over 1160 and multiply by 100 to Pm%. تمام؟ It's almost 1.8% speed reduction. It's not even 5. Or يعني maybe the expression here يعني the author would like to refer that you have a maximum 5% reduction in speed if you change the voltage by 20%. This is not for this problem يا شباب. It may be يعني ايه يعني meaning for a general or any other motor يا شباب. You have maximum of 5% reduction in speed with 20% reduction in volt. However, here in our problem we have only 1.8% speed reduction. طيب. Another variable يا شباب which is frequency. For frequency control, let's see together the advantages of frequency control and what is the effect of increasing or decreasing frequency. If we say increase the frequency شباب, now what will be the effect on all of the all of boundaries? طبعا increasing frequency will lead to increasing in NS. So this is now the direction of frequency increase. صح يا شباب؟ As you can see, NS is increasing by increasing the value of frequency. طيب, what will happen to Tmax? Actually, Tmax here, omega S is proportional with F, and X equivalent also we have F here. So this is now F squared in the denominator. So if you increase frequency, T maximum will be decreased. As you can see, T maximum is decreasing here يا شباب by increasing the switching frequency. Type, sorry, by increasing the frequency of the machine. Type, what will happen to S maximum? طبعا S maximum is proportional with X equivalent in the denominator, which is a function of F as well. So by increasing frequency, S maximum will be decreased. But take care, decreased in terms of NS. So it will not appear at the same point in the curve because NSA has changed. However, يعني decreasing S maximum, يعني this is healthy because if S maximum decreases, the efficiency will be increased because we said before, ideal efficiency of the machine equals 1 minus S. And if S maximum decrease, for sure S will be decreased. So this is now يعني, a benefit in terms of the efficiency. So this is now the response يا شباب if we decreased the frequency. طيب, if we have fan load torque يا شباب, fan load torque, which means for instance like that. أو خليني أجيبها كده شوية. Assume this is a fan load torque. As you can see, speed can change gradually with the curve. However, we all of time يا شباب take care about the linear part of the curve, not the other part, because the other parts are not stable as we discussed before. تمام? So for this load curve, for instance, we need to consider the 3 curves here. تمام? Not the other 2 curves here. As you can see, speed is changed or increased. Okay? Even it's يعني in the second case here يا شباب, this is case number 1, this is case number 2. As you can see in case number 2, it's greater than the synchronous speed of the first case. صح ولا غلط؟ This is because we change the frequency. So you can increase the speed whatever the value may be higher than the rated of the machine. But you have to take care about the machine bearing, because there is a maximum speed for the machine bearing. Otherwise, you may damage the bearing of the machine. So this is the advantage of, this is a characteristic or the performance if we increase the frequency. طيب, let's see the important notes here, شباب. Firstly, motor generator set was used to generate supply with variable frequency. This is, شباب, how we can make it experimentally. يعني conventionally, the frequency can be controlled or was controlled by using something called motor generator set. Motor generator set, شباب, is nothing but DC motor connected to synchronous generator, and by means of controlling the speed of DC motor, we can control frequency of the synchronous generator. So in order to control an induction motor, you need to bring another two machines in order to control one motor. طبعا يعني in terms of cost and يعني economic operation, يعني it's very bad. يعني two machines to operate one motor, it's not logic. However, now we use frequency converters or power electronic converters. Like what, شباب? Like AC voltage controller, which is AC chopper, but it's controlled by another technique called on-off control technique. What we have described before for AC chopper was called phase control. Phase control. However, here we can control the frequency by using AC chopper, also by using something called on-off method. On-off method. It's simply, well, turn on the machine or connect the machine to the supply for n cycles and off the machine. This is n cycle on, and you have m cycles off, and finally one period will be n plus m multiplied by the supply frequency. So you can increase the frequency as n plus m multiplied by f. This is preferred with very high inertia machines for very large power, شباب. However, for small power machines, it's not preferred because the time constant of the machine will be very high. The electrical time constant here will be very high. And in order to control any load, electrical time constant has to be lower than mechanical time constants. So we prefer this technique only for high inertia machines or thermal applications. تمام? But here طبعا this is a motor, so we can say it's high inertia machines. طيب. Another device, شباب, called Cyclo Converter, but it's not used anymore. These Cyclo Converters started in industry, as I remember, or the first famous project or well-known project was at 1940 something. So it's very old technique or very old topology, Cyclo Converter. But the used topology now is the back-to-back converter. This is the most one used for frequency control in industry. Right. What are the advantages and disadvantages of frequency control? First, regarding the disadvantages, because it's dangerous a bit, core saturation may occur at low frequencies. You know that EMF is proportional to frequency multiplied by flux. So flux, from here we can say flux is proportional to EMF over frequency. So what will happen if you reduce the frequency? Flux will be increased. صح ولا يا شباب? So if the frequency reduced too much, the flux will be saturated. And if the flux is saturated, the machine will not be controlled anymore. So we have to avoid operation at low frequencies. So this is here considered as a limitation. Also, as you can see, T maximum decreases, and this is because the frequency increases. And also, this is not preferred with maximum with torque load constant شباب. So we do not prefer the increasing a lot the value of frequency. طيب, another important thing يا شباب, but it's not written here. If the frequency increased, what will happen to the flux يا شباب? Flux will be decreased. طيب, جميل. We have also another limitation for flux decrease called field weakening. Field weakening. If the machine reaches to the field weakening, the machine will be overspeed, and this may damage the bearing of the machine. However, field weakening is already a control or a mode of operation needed in some applications in industry. Okay, but you have to consider the design of your machine. If you are going to make field weakening for any machine, you have to consider this in the bearing of the machine. طيب, this is for frequency شباب. We did not say the advantage. The advantage is that wide range of speed control, because as you can see, you can control it with very wide range. طيب, in order يعني in terms of flux now يا شباب, we can control the machine but keeping flux constant if we keep V over F constant. So simply, we have another technique which is the preferred one in industry, which is called variable voltage, variable frequency, or constant flux operation. For this technique, شباب, we can control V and F at the same time and keeping the ratio V over F constant. If this is happened, the flux will be constant all of time. And if the flux is constant, this is going to keep maximum torque constant. So the advantages of constant flux or variable voltage, variable frequency is excellent for both starting and speed control. You will have T maximum constant. This is one of the important advantages. T starting will increase, which is useful for constant load torque. However, I starting will be constant, which means you cannot reduce the current at starting. But it's wide range also of speed control. So the limitation here is only the starting current will not be decreased, because yani for starting problem of induction motor, we need to decrease the starting current. In terms of characteristic, شباب, if this is speed and that is torque, you will find the machine characteristic moving in this shape. For different frequencies, F1 is the greater because here we have the highest NS, NS1, NS2, NS3, and so on. As you can see, T maximum is constant all of time. And for on the other hand, here you will find current is constant at starting, okay, and this is the speed of the machine. So this is the current speed characteristic, and this is the torque speed characteristic. طيب, how we can make variable voltage, variable frequency control? Simply, شباب, this is the diagram showing, or schematic diagram showing the PWM inverter. طبعا PWM inverter شباب, it's supplied by constant DC. طبعا constant DC can be obtained from a rectifier, or we can use as back-to-back converter. The first converter will provide constant DC, which is rectifier. The second converter is the PWM inverter. So we supplied here constant DC, and the output of the PWM inverter is connected to the three-phase motor. This is our induction motor, and it's controlled by means of pulse width modulation. What's the meaning of controlling by pulse width modulation? Firstly, we sense the current and use this current mapping with the speed in order to make speed control. This is to get the actual speed, and this is the command of the speed what we need to obtain. And by comparing this and making control, here we have like P control now. This is P control, and here we have integration. So this is like I control. So this is PI controller, شباب. And based on that, we will generate some pulses from a controller by using pulse width modulation techniques. So finally, we will have a rotating vector with a magnitude of V and angle of alpha. So the aim here is a vector control, to make a vector control by providing V at angle alpha. This is called the شباب space vector. It's for 3 phase. ماشي؟ يعني I'm not sure even if for who already learned the course of 460, did you learn the technique called space vector pulse width modulation؟ شباب اللي خدت ال 460 course, did you learn the technique called space vector pulse width modulation?
I don't think so.
طيب one of the control techniques شباب which is used a lot in industry which is based on vector control. This is our vector, what we need. This vector represents the 3-phase voltages. Okay, so simply by this vector we control the 3-phase voltages. يعني how we can do that? يعني I can share with you some mathematical derivations showing how we can control or represent 3-phase voltage by a space vector. So one vector can represent the 3-phase voltages. Okay, vector control is used a lot, شباب. It's based on something called space vector pulse width modulation, and it's used for all of the machine types now of control, like field-oriented control, like direct torque control, like model predictive control. And these are the most well-known techniques used even in industry or still in investigation and research steps. Field-oriented and direct torque are used now in industry. However, model predictive control it's still under investigation. No company has used model predictive control yet. It's still in research stage. But field-oriented and direct torque, it's used now more than 50 years, I believe. The most well-known now is direct torque control. It's better than even field-oriented, and it's used or invented by ABB company. Okay, شباب هم اللي عملوا التكنيك اللي هو direct torque control. طبعا شباب in any company now there is a branch called R&D, research and development. They doing research like academic people, okay, and they develop the technique which is called direct torque control. It's one of the techniques used to control induction machine, and it's based on space vector or vector control of the machine. So finally, the decision will be a vector, and this vector can be translated as some pulses which will drive the inverter. This is what's called the شباب variable speed drive. Inshallah, this will be the last topic in our course. What is the variable speed drive and how we can control it? This will be discussed in details at the last few weeks, inshallah. Right. So this is شباب regarding variable voltage, variable frequency control. One more thing, شباب, we prefer variable voltage, variable frequency control up till the rated voltage. We do not increase the voltage over rated in order to avoid any problem with the machine insulation. If you would like to control the speed in wider range after rated volt, you can only control frequency. So in this case, شباب, we can say that this is considered as constant torque operation from this portion to that portion. It's called constant torque operation because flux is constant. However, the other part here can be said as constant power or weakening. Weakening, why? Because the power will be constant and you will increase the frequency, and if we increase the frequency, the flux will be decreased. So we call it as field weakening, okay? And it's used a lot شباب for the part of overspeed. Overspeed, which means greater than the synchronous machine rated speed. تمام شباب؟ So this was one of the most preferred technique for variable for a speed control of induction motor. We will stop here at this point today, inshallah, and next class we will discuss more details about the converters and solving some problems regarding this technique. Any question, شباب? Any question?
I have a question regarding the midterm exam.
Okay, let me first stop recording in order to avoid any problem with the length, and we can discuss any question here.